Evaluate the integral x squared plus 2 over x minus 1 times 2x minus 8 times x plus 2 dx. First, we observe that the integrand is a rational expression. The degree in the denominator is 3 after we distribute the factors, and the degree in the numerator is 2. Since the degree in the numerator is less than the degree in the denominator, this rational expression is proper. The denominator is already in factored form. There are 3 distinct linear factors in the denominator of this rational expression, so we're ready to rewrite this using partial fraction decomposition. X squared plus 2 over x minus 1 times 2x minus 8 times x plus 2 equals a over x minus 1 plus b over 2x minus 8 plus c over x plus 2. There are 3 terms. Each has the constant in the numerator, respectively. We can use the method of undetermined coefficient to find a, b, and c by setting up the system of equations and find a, b, c, but we will use the cover-up methods, which is the shortcuts. To find the coefficient a, we would plug in the x value that would make the denominator of a equals 0. In this case, x minus 1 is 0 when x equals 1. We then plug x equals 1 into the expression on the left-hand side, or the given expression, preferably in the factored form, if it is not already in the factor form. This is x squared plus 2 over x minus 1 times 2x minus 8 times x plus 2, but we need to cover the factor x minus 1. Otherwise, if we plugged in 1, we will have 0 in the denominator and we cannot divide by 0. Once we covered it, this is why this method is called the cover-up method. We would plug in 1 squared plus 2 over 2 times 1 minus 8 times 1 plus 2. There is no need to evaluate the factor x minus 1 because we already covered it. Simplifying this, the numerator is 3, the denominator is negative 6 times 3, so this is negative 1 over 6. So the coefficient a is negative 1 over 6. Similarly, to find the coefficient b, we would need to plug in the x value that would make the denominator of b equals 0. 2x minus 8 equals 0 when x equals 4. So we will use x equals 4 so that we will not divide it by 0. When we plugged in x equals 4, we would need to cover the factor that would make the denominator equal 0, and that factor is 2x minus 8. So we would cover this factor. We then plugged in 4 squared plus 2 over 4 minus 1 times 4 plus 2. The numerator is 18. The denominator is 3 times 6. 18 over 18 is 1. So the coefficient b is 1. Similarly, to obtain the coefficient c, we would need to plug in an x that would make the denominator of c equals 0. X plus 2 equals 0 when x equals negative 2. But we would need to cover the factor x plus 2. When we plugged in negative 2, we obtain negative 2, the quantity squared, plus 2 over negative 2 minus 1 times 2 times negative 2 minus 8. And again, we already covered x plus 2. The numerator is 4 plus 2 or 6. The denominator is negative 3 times 2 times negative 2 is negative 4. Negative 4 minus 8 is negative 12. So this is 6 over 3 times 12, or 1 over 6. The coefficient c is positive 1 over 6. We then rewrite the given integral using the partial fraction decomposition. It is now the integral of negative 1 over 6 over x minus 1. It has to be the coefficient on top of x minus 1 because we use x equal 1 to find a. A is negative 1 over 6 plus b is 1 over 2x minus 8 plus c is 1 over 6 over x plus 2 dx. We then find the antiderivative of each of the terms easily. The first term has the antiderivative of negative 1 over 6 ln of the absolute value of x minus 1. The second term is ln of 2x minus 8 times 1/2. Notice that we can also factor out 2 in the denominator to get 2 times the quantity x minus 4. The next term has an antiderivative of 1 over 6 ln of x plus 2, and don't forget to add a constant c. This is the antiderivative we're looking for the given integral.